everybody, welcome back. Today's lesson is going to be for Tuesday, March 24th. I hope everybody is doing well. We are going to pick up with slide number 26. Here's the song I was telling you about. Again, please keep me posted if things are not working or something seems off, let me know. Again, hope everybody is safe and healthy and that your distance learning is being very successful so far. All right, so we're going to go ahead and pick up with slide number 27. I will have this linked for Tuesday's information so that you can watch that on your own. Just a little sad. I think I might have to play it on my own because I kind of miss hearing our stuff. All right, so we're going to get into kind of the nitty-gritty, the practical stuff for us now. Right, so you should, some of these words, actually most of these words should start looking familiar. They're in your vocab. Make sure you're doing your Mad Minute every day. Whether that is on Quizlet and using the digital version or whether it's your paper version, that is totally up to you, but do it every day. All right, so the atomic number. We are going to take a look at this. So on our periodic table, there are some numbers, okay? And so obviously it might help you if you have this out while we're going through some of this, just to kind of let you know. But each element on the table has its own little card, its own little square. And on that square, it has this atomic symbol or an abbreviation. So this is helium, hydrogen is H, oxygen is O. So some of them kind of match, but like gold is AU, I believe. And so some of the abbreviations or the symbols match their Greek or Latin name, not our American or English version of the element. So some of them make sense, some of them seem a little like, well, where did that come from? And that's why. So you'll also see some numbers on these cards. It would make it a lot easier if they always put the atomic number in one spot and the mass number in another spot, but they do not do that. Some versions of the periodic table will have the mass number at the top, some will be at the bottom, or vice versa. So you have to know that the mass number is always going to be your large number and that the atomic number is always going to be the small number. And that's something that I'll emphasize a lot because you can't just automatically know, oh, the atomic one's the one at the top, because different periodic tables will have that different. On our periodic table, the small number or the atomic number is on the top. So if you take a look at those, you'll notice that, but not all periodic tables are that way. So just kind of be aware of that. You can't memorize like where on that little square these certain numbers are going to be, okay? So the atomic number identifies the element just like a fingerprint. So we all have a fingerprint and that identifies us. It's unique to us, all right? And so the atomic number is also unique to the element. So all atoms of the same element have the same atomic number, okay? So all heliums will have a number 2. If it's not a number 2, it's not helium. And it's because the atomic number is equal to the number of protons. So when you think atomic number, think protons. In a neutral atom then, the number of protons is going to equal your number of electrons. Because if you have 2 protons, you'd have to have 2 electrons to balance that and make it neutral or cancel out. So kind of by default, if it's neutral, you know the number of electrons if you know what atom you're dealing with because you know the atomic number which matches the proton number. Okay, so here's the thing. Protons with a P are permanent with another P. And so changing your number of protons will change the element that you're dealing with. So hydrogen has 1 proton. Helium has 2. Lithium is always going to have 3. And it just keeps going as you go across the periodic table, 1, 2, and then drop down 3, 4, 5, 6, 7, 8. And so as you read across, it's going to increase by number of protons. And then you go, just like you would read like in a paragraph, you would drop down to the next row and you would keep reading. And then drop down to the next row and come back. And as you do that, you're adding a proton every time. And that's why as you move from square to square on the periodic table, you're changing elements because you're changing the number of protons. So the key here is proton number is permanent and it's always going to be like the identifier or like that fingerprint to identify the element that you're dealing with. There's also something called the mass number. The mass number is your number of protons plus your number of neutrons in an atom. So this is going to be the big number, right? Because you're including two subatomic particles, protons plus neutrons. Don't try to memorize this. Use logic and common sense. The atom is small, the atomic number is small. Mass number sounds like massive. Mass means big. If it's big, it's because it's including two parts, not just one. So here it's including the entire nucleus. So it's taking the protons and the neutrons, and that's your mass number. So in this example, they're putting the mass number at the top and the atomic number at the bottom. All right, so again, that's why you have to realize the big number on the card will always be the mass, no matter where it's located, and the atomic number will always be your small number, no matter where it's located. All right, so here is an important slide. This will help kind of keep things straight for you. So the atomic number is the smaller of the two, making the mass number the larger of the two. Think of an atom and how small it is, just like its number. And then think of mass number. You hear the word mass in it, and the word massive meaning large. So massive is large, think the mass number is large. This only includes the proton. One subatomic particle is going to be smaller than when you count two, because over here, you're counting two, the proton and the neutron. Okay? If you look at the bottom of your periodic table, I have written a few things on here for you. In the neutral atom in the middle, it says the number of protons equals the number of electrons. I also wrote the mass number minus the atomic number equals your number of neutrons, right? And I'm going to write this on the board here, just so you focus on this. Oh, there we go. All right, so let's do it down here. The mass number minus the atomic number is going to give us our number of neutrons. And here's why. And I have this already on the bottom of your periodic table for you, but this is, I just want to point it out because it is important. So the mass number includes protons and neutrons. And if you subtract that from your atomic number, that just includes your number of protons. And so if you subtract protons from protons and neutrons, those will cancel out and you're left with just neutrons. So again, try to think of this logically, not trying to memorize it. But again, this very thing is on your periodic table that I gave you, or that is scanned in Google Classroom for you, and it has that right here on the left. It also talks about neutral atoms, and it also talks about ions, and we'll talk about those later. Okay? So again, this is an important idea, because this is the only way that you'll know how many neutrons, because there's no number on the periodic table or on those squares that tell you where, or excuse me, how many neutrons there are. So you have a mass number and you have an atomic number, but you don't have a neutron number. All right, so you have to know that in the mass number, that's protons and neutrons, and here it's just protons. So if you subtract those ideas, the proton plus neutron minus the proton, you're left with just the neutron. The other thing, there's no number for electron, but by default, remember, if it's neutral, the number of protons will equal your number of electrons. So you have to keep those ideas in mind, and that's really important, because the periodic table only gives you so much information, and then they want you to kind of conclude or deduct using what you know, how to get the other information that you need, like the number of electrons and like the number of neutrons that it might have. Because that little square is small, you can't have a number for everything, so we have to use our common sense to do that. Okay, so let's take a look at this. So if you look at your periodic table, helium, all right, is in the top right corner, and it's done for you. The small number, the atomic number, is 2. The number of protons is 2. So by default, the number of electrons is 2. The number of neutrons is going to be 2, and I know that because of my mass number, which is on the periodic table. You see a number 4 on that helium square. So if you take the mass number and subtract it from the atomic number, that will give you your number of neutrons. So the mass number minus the atomic number gives you your number of neutrons. That's the only way to determine how many neutrons you have. Okay, so carbon 12. Carbon 12 is our typical carbon. And so if you look at the C on your periodic table, the top number on our chart is the atomic number. It's the small one and it's a 6. That's where that 6 came from. Now, if I have 6 proton or an atomic number of 6, then I have to have 6 protons as well. And if I know that my mass number is 12 because I'm looking at my periodic table and it has 12.01, we can always round to the nearest whole number. So I have 12 as my other number on my tile on the periodic table. So 12 minus 6 will give me another 6 over here. Now we're going to talk about a special type of element that is called an isotope tomorrow. Isotopes are elements that have a different number of neutrons than the rest of them. So most carbons are carbon 12, but there are a few that are called carbon 14. It still has to have 6 as your atomic number because it's still carbon. And remember, that's the fingerprint, that's the identifier. That means it also has 6 protons because those numbers are always going to equal each other. Now here's what's different. Carbon 14, the mass number is given after you name the element. So here is carbon 12, which matches the mass number. It's not an isotope, it's just regular old carbon because that matches the mass number on the periodic table. But carbon 14 is not on the periodic table. It's a version of carbon, and we know that because it has the same atomic number. But it's now telling me I'm dealing with a mass number of 14. So the mass number always follows the element. So my mass is going to be 14. So now when I take my mass number minus my atomic number, I am left with my number of neutrons, which is in this case 8. So this carbon is not identical to this carbon. It has the same number of protons, which makes it carbon, but the number of neutrons is different, and that's an isotope. And again, we will get into that a little bit more, I think tomorrow it is. That leads us to oxygen. Oxygen on the periodic table is right here. It has the element, shows you that there are 8 as your small number or your atomic number. And so that means by default you have 8 protons because those always match. And if it's neutral, then that's how many electrons you'll have. And then the mass number is going to be 16. And so if we take 16 minus 8, we will get 8 here. And this isn't the isotope version because when you look at the oxygen here, it actually has a mass number of 16.00, which is the normal mass for oxygen. Okay. So this is the general information that you can get just by looking at the 2 numbers on the periodic table for each element that's given. All right, so you have to know that the atomic number is always going to equal your number of protons. If it is a neutral atom, then it will also equal your number of electrons because those will cancel out and balance. And then your big number is going to be your mass number. And then you subtract that from your atomic number to get your number of neutrons. So on this table, you might want to put the small number, big number. You might want to put that these will equal each other, right? And again, mass number minus atomic number equals number of neutrons. And this is the only way you'll know how many neutrons you have. It's the only way. There's no number on the tile that will tell you neutron number. You have to kind of just be a good detective and know take what you know and apply it. Okay? And I think, check my notes, I believe, yeah, let's go ahead and we are going to stop there for today. Please make sure that you start with that song and enjoy, play it as much as you'd like, and I will see you again soon. Have a great day.